Hello students, welcome everyone to the last question for the sample paper of BSDS 2024. We're at question 32 and we have to find the center of an ellipse. Now finding the center of the ellipse is quite easy when it's given in the desired format, right? But here the format is not what we are used to. The usually common format of x minus h whole square by a square. We have that format, right? Uh, this one, I hope you remember. Usual format, this x minus h whole square by a square plus y minus k whole square by b square equal to 1. Then you have the center as h comma k. Now this would have worked if we did not have this xy term, right? But we have that term, so we have to look into the general formula of ellipse. So what is the general form? The general form of the ellipse is, let me write it down for you, it's ax square plus bxy plus cy square plus dx plus ey plus f equal to 0. This is the general form, right? Now when we have this in the general form, let us set fxy equal to the general form. Alright, I'm not writing that entire thing again because you can understand. This entire polynomial, set it to be fxy. Now the simple trick to find out the center is calculate del f del x del f del y and solve. Right, this is how you get the center of the ellipse. Now these are partial derivatives. Partial derivatives are much more easier than normal derivatives. So here what do we have for us? According to the given problem, we have fxy equal to, let us write it down, x square plus 2xy plus 2y square plus 2y minus 7, right? Now once we calculate del f del x, we take everything apart from x to be constant. So derivative, this will be 2x, this will be, y will be constant, so it will be 2y, everything else is constant, right? So we equate this to 0. That means I have x plus y equal to 0. So this is our equation 1. Alright, it's the center will be a solution of uh, these. Alright, take these to be 0 and solve. So now del f del y, what will be this? X square is gone. Here I just have 2x, right? Because derivative in terms of y will be 1 and the coefficient will be 2x. For 2y square it will be 4y, right? 2y square, yes, because it will be 4y, yeah, and plus 2, right, equal to 0. So that means I have, if I cancel by 2, I'll have x plus 2y equal to minus 1. Now I can just subtract these, right? I can do 1 minus 2 and I'll get y minus 2y equal to 0 plus 1, right? Because minus of minus 1, that means y is equal to minus 1 and x should be equal to 1. So therefore center, we have got it, center equal to 1 comma minus 1. Check the calculations here once. While we're partially derivating in terms of y, x square is gone because x is constant here. Y, the derivative of y will be 1, coefficient will remain, you will have 2x here. For 2y square you will have the 2 in the coefficient, 4y, and then 2y will give you 2. So x plus 2y equal to minus 1. Now if you subtract this, you will have minus of minus 1 here, which will give you plus 1. Alright, you are subtracting it. So y minus 2y equal to plus 1, which means you are going to have y equal to minus 1 and x equal to 1. So therefore the center will be x comma y. The center here is 1 comma minus 1, option B. Alright, now if this sum was given to you in board exams, they would have given it to you without the xy term. You would have to, take the polynomial, find out the whole square and put it into that format. x minus h whole square, right? That is the format that is preferred by boards. But ellipse has a general form, right? Xy term will also give you an ellipse. So for that, you take the partial derivative of x with respect to x, take the partial derivative with respect to y, solve those two equations, you will get the center. Okay, check the calculations. I hope they are easy to understand, and if you have any doubts, do contact us at the numbers that are given there in the comment section. Alright, so I'll all see you for the solution of a different paper. Thank you all for viewing all of the solutions that we posted, and if you have any doubts or you feel some of our solutions have an errors might creep up, right? Because all of us are doing this for the first time and then posting for you all. So if you find that there are any errors, if any clarifications are needed, do let us know in the comment section. Okay, that's it for now. I'll see you all in some other video.